Hey guys, today I'm going to tell you a story about the square root of 2 and how we know it's an irrational number. Alright, let's get started. So, way back in ancient Greece, there was a school of mathematicians called the Pythagoreans. We know two big things about these Pythagoreans. First, they believed that all numbers were fractions. Using modern math terms, we might say that their belief was that any number n was equal to a over b, where a and b are both integers. The other thing we know about the Pythagoreans is the Pythagorean theorem. As we all learned in middle school, in a right triangle with legs of lengths a and b and a hypotenuse of length c, a squared plus b squared equals c squared. Well, this is the way we've always looked at this theorem. The ancient Greeks didn't have the algebra system that we use today. This system wasn't used by Westerners until around 1200 AD. The Pythagoreans would have seen this picture, where the geometric square created by one of the triangle legs plus a square made from the other leg equaled the square created by the hypotenuse. Alright, so now that we know about these two big Pythagorean beliefs, it's time to meet Leo. Leo was a student at the Pythagorean school. One day, he was looking at a square tile, with each side measuring 1 unit in length. Leo realized that there is one other length in the square, and that's the diagonal. He wondered what this length could be. By using the Pythagorean theorem, we could say that 1 squared plus 1 squared equals c squared, 1 plus 1 equals c squared, 2 equals c squared, or that c is the square root of 2. So when Leo found that this length was the square root of 2, he asked himself what fraction was equal to this, since all the Pythagoreans believed that all numbers were fractions. In trying to find a fraction equal to the square root of 2, we may say that it is equal to a over b, where a and b are relatively prime integers, leaving us in search of this a and b. Now, as Leo did not have access to modern algebra, I'm not sure how he came to the conclusion we're about to find, but here's how we may approach this problem today. First off, we'll set the square root of 2 equal to a over b, assuming that a and b are relatively prime. Otherwise, we could divide out any shared factors between the two of them and reach a new a and b which would be relatively prime. Now, no one likes stealing the square root, so let's square both sides first. Now we're able to multiply both sides by b squared to get rid of all fractions. Now we know b is an integer, and by the rules of math, b squared is also an integer. 2b squared is therefore an even number because it's 2 times an integer. And since a squared is equal to 2b squared, that means that a is also even, or 2 divides a squared. Proof by contrapositive will show us that when a is an integer and a squared is even, then a must be even. From this, we know that 2 dividing a squared, 2 divides a, that a is also even. Alright, so we've shown that a is an even number, and if it's even, then there is some integer c that is half its size. So we can set a equal to 2c. We'll go ahead and plug that into our original equation now. We'll make the same simplifications as before and reach a point where we say that b squared is equal to 2c squared. Now, by the same logic as before, we know that 2c squared is clearly an even number, meaning b squared is an even number. And since b squared is even, we know that b is also even. So now we know that the square root of 2 is equal to a over b, where a is even and b is even. But wait, that's not right. We claimed that a and b were relatively prime numbers, but we've just shown that they're both divisible by 2. This contradiction counters our original assumption that there was such a rational number to that square root of 2 is equal to. We assumed we could write the square root of 2 as some fraction, but it turns out that that is impossible. Square root of 2 cannot be expressed as a fraction and is an irrational number. So Leo came to this result. He went to his classmate and said, "We've got it all wrong." His classmate wasn't really sure how to respond to this, so they went to their professor and showed him their work. After some thought, the professor suggested that they all go fishing. So Leo and his classmates got in a boat and went out on the sea to fish. Now this was when Leo's classmates grabbed him and threw him overboard, where he drowned. The Pythagoreans were not yet able to break their status quo upon which all of their mathematics had been built. Years later, they'd realized their mistake, but it was too late. Leo was dead. The end.